Today's quest is all about astrophysics, and with me today, Athena Brensberger. Life is a quest for logic and reason. It is a quest to find balance between science and faith. Life is a quest for knowledge and understanding. But most importantly, it's a quest for personal discovery. Whatever your quest, knowing yourself is the beginning of all wisdom. Welcome to Quest. Hello everyone, I'm your host, Todd Fischer, and this is Quest. For those of you that might be new listeners, let me tell you a little about me. I'm the founder of Metacortex and the author of the best-selling book, Metacortex, The Grand Design. I'm a philosopher, a theorist, a metaphysicist. I'm a perpetual pupil of theology, and I'm an expert in comparative religious study. I've also extensively researched the mind-body connection, anatomy, and physiology. I documented over 300 case studies while researching my book, all from a scientific perspective, with cases that ranged from near-death and out-of-body experiences to possession to past life experiences, as well as the metaphysical, the paranormal, and other unexplained cases of a spiritual nature. This podcast will bring you some of those astonishing stories, and in some cases by the people that actually lived them. From time to time, I'll be talking about important, perhaps even controversial issues from both spiritual and scientific points of view. The world we live in is ever-changing, and there's often a conflict between spirituality and science. And I wanted to bring you this podcast to balance that equation. It will show you how we know what we know, and there's still so much we don't know. For me, curiosity is part of what makes us human. It's the joy of discovery. It's what drives us. It's our quest. On today's podcast, I have Athena Brensberger. We had a great chat about astrophysics and so much more. I hope you enjoy it. Hi, everyone. I'd like to welcome Athena Brensberger to Quest. Welcome to the show, Athena.
Thank you. Thanks for having me, Todd.
So Athena is the astrophysicist Barbie, a space evangelist, an astronomy nut, and a fashion model? What? Come on. Really? You're all these things, Athena?
Yeah, and I don't really know even if astrophysicist Barbie is actually a type of category more than just being a toy.
These are all from your Instagram page. So
yep.
Is how you. I love it though. Those are all great things.
I know it's such a weird way for me to put myself as, but I thought it was hilarious.
I love it. I love it. So that's what a great lead-in, right? So let's tell the listeners a little about your background and your education, because everything you do is so fascinating to me. Tell me how you got started with this.
Yeah, so I got started a few years ago with building up this whole social media presence, this platform, because I really found more of an importance in the science industry, specifically in astronomy, to do more outreach. There was a lot of outreach that already existed at universities and schools, but I think it's so important to, experience different outlets of outreach, ways to reach more of the general public outside of the science community, both, kids as well as adults. And when I was studying astrophysics at university, I was going into research and I was doing all the years of learning how to code and going through lots of information and data. And I just realized that the first time I gave a talk on stage about what my research was, that was when I felt myself just exploding with joy and energy, because talking about astrophysics, I realized, was so much of a bigger passion than actually conducting research in astrophysics, which is kind of crazy to say, because a more conventional pathway is to actually become the researcher, become the astrophysicist, become the one who's trying to find life beyond Earth, which was my main goal. But I realized that, there was something that I learned so much through the other outlet which you mentioned as being a fashion model and being an actor, I've learned how to connect with others and communicate. And I think that we need that in science more now than ever, because the space industry is booming so much right now. And I think that there definitely is a lot of info out there, but I think that more people have to find it relatable to themselves in order to even want to pursue that. And so that's become my mission. And that's why I call myself astrophysicist Barbie, because I actually had gotten a Barbie doll from my dad and my sister and recently, like at my current age. I'm not a child. And I just was like, wow, like this is totally me. Like, just this, like just a Barbie doll. Like ever since I was a kid, like people used to joke with me saying I'm like a Barbie. And originally it wasn't in a good context because I don't know. It was like, they were like, oh, you're this like, like bubbly blonde, whatever. But then, and then that's not standard for science. And so I like that there's this hybrid of, this of a Barbie doll, which used to be looked at as this like ideology of like the perfect woman, but really Barbie is such a mix and hybrid of all different models of what a woman is in our reality. And the fact that I saw an astrophysicist Barbie doll, I was like, wow, I'm like, that's so cool, because like, it's just, I don't know. And so I just decided to throw that on my Instagram. Only in March I did that. I just put that on my Instagram in March. And because it's just, my page has so much of my modeling stuff. So people will come and be like, oh, I thought this was space science news, but we also see that, I'm like posting things for my modeling clients. And so it was like, I was like, how do I really show that this is a hybrid of two worlds? And so that's where it is now.
And that's great. It's great overall branding, I think. So, it's funny because like on television for years, like you couldn't cast someone blonde as a doctor because TV would say it wouldn't be believable, and that someone couldn't be too pretty to be in a scientific field. Like it was really crazy. But things have changed so much in that regard now. And I think all these worlds can be embraced, And I'm curious, so were you interested in the stars even as a child? Like how far back does this interest go?
It started when I was 12. 12 was a great year for me.
Yeah.
So growing up in New York City, I grew up in Brooklyn, like there was a lot of light pollution. I was not like the standard, the standard story of how a person follows the stars, where they're like, oh, I looked out at the night sky and saw like millions of stars and knew I had to pursue it. That was not me. I went outside. I was lucky if I could see one star, and most likely it was a planet. It was most likely it was Jupiter because Jupiter's super bright.
Yeah.
So I was 12 years old, and my best friend, who I had just met like that year, so 7th grade, she handed me a book of the cosmos. I don't actually remember the title of the book. It wasn't Cosmos, but it was images taken by the Hubble Space Telescope.
Mm-hmm.
And back then, like I was full on, like I was a competitive ballet dancer. Like I went into like doing training at Alvin Ailey. I was doing art. I was a painter. I was like, I'm going to have a whole career path as, a triple threat. Like I wanted to be a triple threat: singer, actor, and model. And I was like, I'm going to be just a performing artist. But then I saw these images and I was like, wow, these must be paintings. These are incredible. And she blew my mind. She was like, no, these are images of things, real images of things called galaxies and nebulae. And they're in something called the universe, which we're just a tiny little speck of. And these are billions of stars. And there's probably, other planets like Earth out there, and possibly even other life. So, 12-year-old me is having this existential crisis of like, whoa, there's so much more out there. And I'm like, it is my human duty. Like, this is my human right to, like, my purpose to pursue the ultimate career as a human being, which is to find out why we're here. So that's really what started it for me, was this little book of images taken by the Hubble Space Telescope. And
Wow.
It just set me on this path. Yeah, it was extraordinary.
I was probably similar in age when I became interested in space. And it started with a National Geographic magazine that was like a moon special, and it had a map of the moon. It came in the issue, and I was just infatuated by it. And by the time I was 13, I had gotten a telescope. I got it as a birthday present, and I would I grew up in the Midwest, so we had a lot of stars. And I would set that thing up in the front yard and aim it to the moon. And all the neighborhood kids would come by and I would show it to them and show them parts of the moon. And I would just overanalyze that moon map. I tell you, I knew everything on the moon. And then that my interest kept going, and I would buy books on the solar system and learn about the planets and all the moons of all the planets. And I would take that book to school and just memorize it. And by the time I got in high school, I was convinced I wanted to be an astronaut. And I went in an ROTC program, and I got more consumed in this world. But my dreams kind of collapsed because my vision wasn't good, and I'm so old. There wasn't corrective surgery back then, and I started to hear about how difficult it would be to go through the Air Force and then become and then like it all started to like drift away, and then my career took a different path. And I really miss that 5 years or so that I was heavily into this. Was like so magical for me. What are you really into? Are you a fan of Hawking? I think you told me you are.
Yeah, I definitely think that. So Stephen Hawking, who he passed away actually coincidentally on Pi Day, which was also Einstein's birthday, I believe it was 2 years ago. He started working a lot on trying to come up with a theory of everything, which sounds quite heavy in itself, but he was a theoretical physicist, which means he went more into understanding how quantum mechanics works, which is when you zoom down beyond atoms and you start to look at things on a subatomic level. So looking at things of how really, really tiny particles behave. And the thing is, in quantum mechanics, subatomic particles behave very differently than, say, you and I behave, and say the rest of the universe behaves. And I think that's something very important about metaphysics, about Hawking, is that there's this merging of different industries that typically are fragmented. So you look at, astronomy as one thing, you look at microbiology as another thing. But merging those together is where you really can start to find just so much more of awareness, I think, of what our reality is. And if we want to really become like a space exploring species, more than we already are, I mean, we're very space exploring now, robotic wise, but if we want to go beyond that, I think it's very important that we combine these different curriculums together. And so Stephen Hawking was a big, not just a fan of it, but he was very actively working on that. And the first thing that he discovered and realized was something about black holes. Black holes are, these crazy objects out in space that resulted from typically the death of a massive star that could have died. There's actually different categories of black holes, but it's known for pulling in everything that's around it. Even light can't escape, which means that it has such a strong gravitational force. And the thing is, you would typically think that, it's pulling in matter, that's it. Hawking said, well, if we look at how quantum mechanics works, where, say, a particle can have two positions, a superposition of particles is what it's called, two positions at the same time until an observer makes the observation. So he said, maybe, if we apply these concepts of quantum mechanics to black holes, then if an object or an item, a piece of matter falls into the black hole, part of it radiates back out into the universe. And it was just this super interesting concept of, wow, like, if like my wallet fell into the black hole, part of my wallet goes back out into the universe, like, great, I didn't lose all my money type of thing.
Right.
And that's one thing, but then he worked on something even deeper than that before he passed away, known as the no boundary proposal, which looks at the early universe. And he said, okay, maybe if we zoom back enough in time, if we rewind time back to the Big Bang, we see that there was a moment of when, time started, things started expanding, and, matter as we know it today started to form. He said that, well, maybe with a black hole radiating out, it might reach a point where it's no longer pulling in matter, it's only pushing out matter. And this is known as a hypothetical white hole. And this also ties in with wormholes, where a lot of researchers believe that if there's a black hole and a white hole and they have an attachment to each other known as an Einstein-Rosen bridge, or just a wormhole, matter can pass through and go out the other side. This is, very, very hypothetical, but Stephen Hawking said maybe this black hole can reach a point of singularity where no matter is falling in anymore, only being released. And he said, what if the same thing happened with our universe? And maybe at one point there actually was always a stage of existence, but time as we see it or conceptualize it hadn't yet started. And so he looked at it as kind of like an open, like an inside out bowl. Like if you were to turn your bowl inside out or just turn it upside down, there was no boundary. There was no edge of space. There was just always an existence. It's kind of hard to conceptualize, but this is a theory he was working on just before he passed away. And so just looking at that alone, all of that craziness that I just mentioned, and then tying that into metaphysics and questioning, why things happen the way that they do here on Earth, the way that we almost feel, these deeper, higher connections, say to people or to moments or to locations, and deep states of meditation. That's where I think everyone just starts really trying to put the pieces together, the puzzle pieces together. And that's why it's so important that we merge these types of industries.
It's interesting. So, Hawking said that the universe theorizes that the universe doesn't have a boundary. So if we use the example of Earth's rounded surface lacks an edge, the universe doesn't have an edge. So direction, it's interesting because if you travel southward to the South Pole, when you reach the South Pole, the term south loses its meaning, right? So there's, with no edges in the universe, there's no necessarily any direction in space.
That's another thing too. Yeah, the direction in space is completely just dependent on the perspective of the person or the thing or whatever it is that whatever your point of view is. And because in space, even when we're orbiting, when we look at a picture of the solar system, it looks like the sun's in the middle and all the planets orbit around it, and it looks like it's on the singular plane. But space is expanding. So while everything is orbiting, it's also moving in kind of like this spiral all together throughout the universe, because everything is, we're all pushing away from each other. Now, keep in mind, the solar system is bounded by the gravity of the sun. So the orbits of each planet is the way it is because of the gravity of the sun. And so it's held together by that force. But our solar system is expanding just as our galaxy is expanding, just as galaxies are pushing away from each other in all directions. So that even brings to the idea, the conclusion of, well, is there really a center to the universe? And, many people that are working on this don't believe there actually is a specific center, because everything is pushing apart from everything else. So it's very difficult to kind of pinpoint that as well. But yeah, it's so crazy to even think about.
When you obviously going through the public school system, you see a picture of the sun and all the planets lined up left to right. That's like kind of how you see the textbook version of how this stuff works. And I remember someone gave me an example one time, and they said, picture the solar system with the sun to the left and, Neptune, when I was younger, Pluto to the right, and all in a line, and the Earth is situated like normal with a North Pole and a South Pole. And he said, now pick up the solar system and flip it upside down. Now everything's reversed, right? So left is right, up is down. So they talked about our human concept of direction in space can be undone by simply not knowing which way we're positioned in space. And I thought it was really fascinating to me to think about that, because you grow up with this sense of what's north and what's south and but really, are we vertical in space? Does it matter? Is it just simply a human construct around us?
You're completely right. That's what it is.
It's fascinating to me. I think time and space and direction are just simply human concepts, and I always wonder how it can work in something as vast as the universe. It's really pretty incredible to think about. But you don't think that the Big Bang started from one point, that, if there was that dense high energy ball that was necessary for the Big Bang to take place, wouldn't that be the center and everything expanded out from that?
I think that as far as what I would be believing in, as far as theories go, the Big Bang Theory is the model that is withstanding all the other models right now. Though no boundary proposals serves as a great type of like contradiction to the Big Bang. But
Yeah.
as of right now, the Big Bang's model is still that one that is withstanding above all else. So yeah, you would think that that would be like that center, because that's where everything expanded from. But think about, say, you left at your house and you were with someone, but then that person walked away from you, but then you walked away from that person. And then like that center, but you're still having everyone shifting from one another. And so that central area is going to be changing depending on everything else that's moving away from each other.
Right.
So we can't say that the Big Bang really like started, if we were to like look just only at the middle of, say, the cosmic microwave background radiation, which is the leftover radiation from the Big Bang. It's shaped right now, how the WMAP observatory was able to image it, as like this, elliptical shape, this like oval, and it sees it like that. And so to really try and find a pinpoint location is, it's still obviously something that's really even hard to conceptualize. But I think the reason it's hard to conceptualize is like what you said, it's a human construct. And I think that as we start to evolve as intellectual beings, and we can start to remove this way of looking at things in a linear format, is when we'll begin to actually maybe possibly begin to learn to access if there are other dimensions happening around us. We just haven't been able to figure out how to access them just yet, but it is possible that they exist. It's like in the movie Interstellar, where there's a fifth dimension there, and the artists of that movie were trying to conceptualize, how can we make this visual for the audience to be able to understand how a fifth dimension would look? Because we're born into this reality of seeing, like you said, time is linear. Things that we see, like our solar system, we see it as linear. We see things as a plane, but that's not really what things are. And I think that the more we start to apply that like shifting in perspective that exists in the cosmos and apply it here on Earth, then I think we'll start to really reach a new evolutionary stage of humankind.
Right. You talked about space expanding, the universe constantly moving and expanding. Things aren't moving proportionately. Things change in terms of speed and direction in space. Is that accurate to say? Or from the beginning, things are just constantly moving outward? And explain that to me, how that concept works. So does that mean distances between things are also expanding, or is everything moving proportionate to one another, but just outward? How does that work in theory?
So in theory, this has to do with the Hubble constant. So Edwin P. Hubble, who is the Hubble Space Telescope is named after him. He started to derive this acceleration rate of the universe. So the acceleration meaning not just its speed, but an increasing speed. And it's relative to the distance of something. So if I'll take the block as an example again, if someone is standing on the edge of one block, and their friend Bob is standing 2 blocks away, but their friend Alice is standing 4 blocks away, Alice is going to be moving further away at a faster rate than Bob because she's further away. So yes, depending on where things are located is dependent on how fast they're moving away, but the overall acceleration rate is unchanged. So what that means is that overall acceleration rate, so it's still going to be, it's estimated right now to be, I believe it recently was adjusted. It was originally 74 kilometers per second per megaparsec, which I can get into the units in 1 second. But recently, astronomers were looking at the ripple effect of light from the cosmic microwave background radiation and determined that the acceleration rate might actually be about 64, which means either their measurements were slightly off, or that the universe may be slowing down. But this is still, being worked on a lot, and it's way too soon to say, oh, the universe is definitely not slowing down. But what that means is that's the acceleration rate, but it's variant on the distance of an object. So our nearby galaxy is moving X amount away from us, but galaxies that are redshifted, meaning early universe, and they're moving away from us, are moving away from us faster than galaxies nearer to us. So yeah, so things are all being pushed outward by this like unseen force known as dark energy, which is just so crazy to even conceptualize. But yeah.
Which is what I want to move into next.
Oh,
dark
sweet.
matter, dark energy.
Convenient.
So let's talk about dark energy. So dark energy isn't really dark, it's invisible, right?
Mm-hmm.
So tell me the idea behind dark energy, why we don't see it. Are we not traveling fast enough to see it? Is it only speculated to be there? Is the universe being pushed apart? Is this the accelerant for it? What do you think? Where are we at with this dark matter, this dark energy, this world, this unexplored world?
Yeah, definitely. I mean, it's being explored, but it's so tough. I have a few friends that are particle physicists that are working on studying dark matter. And so dark energy is what scientists believe is this outward force found in the universe. It's very mathematically calculated, but as far as visual, that's why it's called dark. It doesn't reflect or emit any light. And so, but it's been measured to be the expanding rate. And what I mean by it's been measured means that based on how much matter already exists in the universe, we should be moving at a certain number. Turns out we're moving faster than that certain number. So there must be some other source. There must be some other force. And so they believe that it is dark energy. It turns out, as a lot of calculations have been worked on, a lot of measurements have been made, astronomers determine to this day that 68% of the universe is made up of dark energy. 68%. That is such a large number.
Yeah.
And then only about 27% of it is dark matter. And then the rest is, everything else, meaning like, you, me, the stars, the galaxies, and the visible elements. Whereas dark matter, the physical properties are still so unknown for dark matter, but like a lot of astronomers, and starting with Vera Rubin, who was studying the rotations of galaxies, noticed that, and this is a great example actually, this is how it was first not really discovered, but understood that there may be something more, is the outer regions of galaxies were rotating faster than the central region. And if you think about it, the central region, if there's a active galactic nuclei, like a black hole, has a strong gravitational force. Things that are close to it should be spinning faster. And as you go out towards the galaxy, things will start to spin slower. Turns out that the outer arms of galaxies, certain galaxies, spiral galaxies, were spinning a lot faster. So there must have been some other gravitational force. Turns out that most likely the implications would lead to it being something known as dark matter, being this inward gravitational force, and that it's causing, movement of matter in our universe. So these are these, just crazy concepts to even think about, that, most of our universe might be the stuff that we don't see. Whereas most people might look at, images of the universe and it's like, oh, it's dark, empty space. There's nothing there except for one or two stars and then some planets. But all of that darkness that we see most likely is stuff that we just can't, it's not in we just can't see it. And I don't mean just in the visible light spectrum. I mean in the whole light spectrum, like heat and energy and other forms. And that's what's so mind-boggling. And that ties again into this concept of, are there other dimensions that we just cannot access yet? because we haven't really developed the technology or the consciousness or our, evolutionary mind. So yeah, stuff is crazy.
No, I love that. I've kind of always talked about this, but I think creation happens in darkness. The Big Bang would have started in darkness. Childbirth starts in darkness. Even the thoughts in your mind are happening in darkness. And so I think that darkness is always fairly fascinating to me. The things that we don't see. There's a lot of great theories about other dimensions and how these things may function. A lot of, this is pulling away from specifically our topic, but it's always interesting in the kind of the metaphysical world, just when you think about things like the idea of whether there could be a ghost or a spirit, and are they operating on a different plane of existence? Are they in some other dimension where they're just sort of partly here or in between? There's a lot of interesting theories on like membranes between like the third and the fourth dimensions and the fifth dimensions, and how these things might be attached and how you travel between them. And then there are parallels in that world into spirituality. And it's fascinating to me how deep people can go with these theories. And I want to take a second, because I want you to maybe answer these questions for me. So for the average consumer that's out there listening to the podcast, where we're talking about deep things that some people can't really understand, how, in your experience in science, how do you research these things? Are these computer model simulations? Is this all math? Is this looking into deep space with telescopes? Like what is the brass tacks here in terms of how you actually conduct this research? Because it seems like it could just all be hocus pocus. Tell me how the science goes into theorizing these things, and then how you go into wanting to prove them.
Yes. Oh, this is such an exciting part. Okay. So it's really a combination of everything you just said. So just looking at it from an astronomy perspective, when looking at, say, star clusters, astronomers a lot of times in star clusters can determine the ages of stars by looking at, their spectrum, by measuring what their composition is, what their mass is, and determining what their age is. And then they're able to see, okay, well, what is the age of the overall star cluster based on, the youngest star that we see here, and then look at the oldest star that we see there, and that's a visual thing. And on top of which, there is a lot of math, like you mentioned, when it comes to particle physics, and you're looking at dark matter. That is definitely not my expertise, so I would recommend like looking into like some particle physicists. My friend Sophia Nasser, Astro Party Girl, she is brilliant on this. This is actually her research. And they look at it from a completely different perspective, looking at mathematically and then applying it to models and simulations, like you were saying, trying to find ways in which we can recreate what we're actually seeing in space, but try to apply it through like a computer simulation, because when you do that, then you start to get the results coming back, the numbers coming back, and then you can be able to derive conclusions of what's actually happening out there. Because unfortunately, with astronomy, it's a very observational science. It's you observe, and then it's very mathematical. Going more into astrophysics, and then into cosmology, and going into particle physics. That is very, thankfully we have our computers, but otherwise, you can't go to, another star system and then collect data. Whereas like here on Earth, all the other sciences, chemistry, chemical reactions, biology, that's very hands-on. And so trying to understand how to make, I think, astronomy hands-on is why it's so math heavy and computer heavy. And so, yeah, so scientists are definitely working on that. And there was something you mentioned that really triggered a thought of mine, which is like dreams and dream states, for instance. I think that that's something really fascinating in itself, because looking at it from a neurological perspective, we know, okay, well, dreams are composed of like, activity in our minds. We reach rapid eye movement. And so the brain is releasing like, beta waves rather than like really high energy frequency. And so it's in this rest state. And then there's a combination of things that we remember from a long time ago, way back in the back of our minds, and then things that we just saw, and then things that we fantasize about. And that's what conceptualized dreams. But then you go into something like lucid dreaming. And you start to wonder, okay, so although we can explain the science of what's happening, we still don't exactly know really why it's happening. Although we can understand like how the brain's doing it, we don't really know what the reason is, you know, other than the fact that we're just conscious beings and we need entertainment while we sleep. But that's, I think, where metaphysics starts to come in with so much of modern day science, because although we can explain X, Y, and Z, we still cannot really figure out like why it's happening. And most scientists will say, well, it's just happening because it's just supposed to. It's just supposed to happen. It's just like that. But I think that that's why I love having conversations with people who are like, but why? But why? But why? And that's why I love working with kids so much, because they'll always ask why. And so that's why, you know, I'm so glad that all the research that's being done today, to go back to your question about how, you know, scientists figure these things out, how they conduct experiments, is just because they want to know why. And like a perfect example as well about light being this crazy phenomenon of, you know, having something known as light behaves in wave particle duality. What that just means is it behaves, you know, duality, so two ways, as a wave and also as a particle. And so what that means is that literally an experiment done by Thomas Young, where he split a light beam and saw that if he put two openings, the light, if it was a particle like a ball, it should just pass through the opening and hit the other side. But instead it split. It would be like if you took a basketball, threw it through the slits. You know, some of the balls wouldn't really go through the slits, some of them would bounce back, but the balls would bounce through, and some of them would almost like tear and rip and smear. They would smear across the entire wall on the back. That's it acting like a wave. And we see this with light, and we see this with other, you know, subatomic particles, so quantum physics. And it's so extraordinary to see that, because then you're like, wait a second, how is something behaving unlike what the laws of physics in the macro world, as I shall say it, you know, in our big world, the atomic world, how does, you know, how is that even possible? And so it's experiments like those that start to show these types of things, derive these types of conclusions. And yeah.
Do you think there's anything that travels faster than the speed of light?
That's a great question, because based on obviously our modern day knowledge, the answer would be no. It would be, of course not. Like, the way that we measure things in space is by looking at the constant of the speed of light. And, you know, but as like also having that scientific mindset, you still want to have a what if all of a sudden we discover something that's, you know, a lot faster than light. And maybe that's why we couldn't see dark matter, but we just can't conceptualize what it really would be, because it might be another sense of ours that as human beings, we don't have that. We haven't developed that sense just yet. And maybe it's not the you know, the sense of seeing, the sense of smell, the sense of taste, the sense of hearing. Maybe it's some other type of sense. I mean, maybe it's tied in with the sense of touch. I mean, who knows? But I think that's why, we're seeing so many bigger questions being asked today. And I think that's why also we saw like Stephen Hawking, for instance, working on Universe in a Nutshell, A Brief History of Time, looking at what is time? How does time dilate? What is like Einstein's theory of special relativity? Time dilation. You know, like life on Earth is completely different than if we were to go to another planet. It's crazy.
So traveling faster than the speed of light, would you see the beam of light traveling next to you? Would you see it in slow motion? Would you see the beam?
Well, if we're moving at the speed of light, and that's something super crazy to even conceptualize, is all of our physical matter would be broken down. We would just be turned into photons, which is what light is. We would just be light energy. So what would happen with our, you know, our way of being aware, our consciousness, our awareness? What would happen with that? Would we just die? You know, like if we're going to start moving at the 3 million meters per second, which is the speed of light, how would we even, you know, do that? And so if you're moving not at the speed of light and you're in a spaceship and you're moving relatively fast and you see light, you would just see it still move way faster than yourself, and you wouldn't even be able to slow down to catch it. It would just go back. It would go by in an instant if it was just a singular, beam of light, for instance. But if it was like, constant light, constantly, moving, then, we would still see it, but it would be moving at that 3 million meters per second and just go right past us.
Yeah. It's so fascinating. Crazy. It's fascinating. I often wonder, so a lot of physicists that I know are atheists. Mm-hmm. There are a lot of astrophysicists that I know that aren't. And I'm curious, can science and spirituality coexist?
I think it can. Yeah. I feel like the reason that I think it can is because spirituality drives a lot of question and curiosity. And it drives a lot of, most people that I know go into spirituality, whatever that outlet may be, whether it is following a specific religion or it is just, believing and meditating with oneself and connecting to Mother Earth. I think that spirituality is led to with people because they want answers. And so because they want answers, they look to the areas of science that are trying to find those answers. And I think that that's why we see this coinciding, this combination happening a lot between these two things. And so I think that it can really serve as the fuel for one another. And I think that it's very important to have them intertwined.
Excellent. I have a couple just fast alternate questions that I want to ask you before we wrap up today. Mm-hmm. So the Planet X theory, is there a planet that's out there with such a long elliptical orbit that we haven't seen it in recorded history? Is there going to be this Planet X, this 10th planet or 9th planet or whatever, zoom by at some point? Mm-hmm. Is that possible?
So I love that, because if you were to look at Pluto, for instance, which bummed so many people out when the IAU declassified it as being a planet.
It upset me.
The thing is, it's called a dwarf planet. It's still technically has the word planet in there. So if they don't want it to be a planet, then just call it something totally different. But if we were to categorize Pluto as a planet, there are thousands of other things that are like Pluto just within our solar system. And so if we were to categorize Pluto as a planet, then we'd have to categorize thousands or hundreds, it might not be thousands, hundreds of other rocky bodies as planets. A friend of mine is a planetary geologist at Johns Hopkins University, Dr. Kirby Runyon, and he is an avid Pluto extraordinaire, I would call it. He calls Pluto a planet. He says Pluto's a planet. And he says, and there's hundreds of other planets within our solar system. And the thing is, but are we going to want to teach that? Or we want to just stick it to the 8 because it's easier? So what I usually will say is, okay, there's 8 main planets, and then there's all these other ones. So as far as Planet X goes, it's possible. If there is something, I haven't read too much up on Planet X and it having a super elongated orbit. But if you were to look at something like 2020 C3, I believe was the name of the moon. We had another moon of Earth that passed by sometime around March, and astronomers categorized it as a second moon. It was a mini moon. It technically was a space rock, but it became part of Earth's orbit. So it was gravitationally bound to Earth, lasted here for 2 weeks, is traveling back out into space, but will be returning in about, I believe it was 74 years. It was either 58 or 74. And when it's going to be coming back, and it behaves differently than, say, an asteroid, behaves differently than a comet. And so it was classified as a mini moon of Earth. And so these things, I think, should be proof that we should remain open-minded when it comes to our universe and when it comes to science. Because if we stay concrete with, well, my textbook said there's only one moon of Earth and there's only 8 planets in our solar system and all those other ones are bogus, then we are actually hindering ourselves from reaching greater milestones in astrophysics and also in just generally our own science. And I think it's because so many times humans just want to know. We just want to know and be concrete, know that that's the fact and that's that. But I think that that's why it's so important to merge, say, spirituality and science. Do that. It's daring. Most people are afraid of doing that because they're like, oh, I can't ever even think about saying the word Jesus. I can't ever think about saying, you know, the word that evolution to my kids, or, you know, vice versa. And I think that those things, those uncomfortable moments are vital in our evolution. And so, yeah, so I mean, if there's a Planet X, come on and visit us.
Yeah.
That would be awesome.
Well, there's an interesting series of books called The 10th Planet, which Zecharia Sitchin wrote.
Yes.
Which had kind of became their own religious movement for a while. Like, it was really pretty crazy that humans were seeded from this 10th planet. And although I think he had a lot of flawed mythology, and there were mistranslations of Sumerian texts, there are some things that are actually factual that he wrote about. And it's always interesting to me to think about that, you know, there might have been something that had such a long trajectory around the sun that, you know, that civilization could thrive for, you know, hundreds, if not thousands of years before the planet would just freeze itself out, and they needed a way to get off of it. It's really interesting science fiction in a way, you know, to think about that there could be things with such a long orbit that, you know, it hasn't come back since we've been advanced as we are now to be able to record these things. It's interesting.
Yeah.
So time travel, can it happen? What do you think?
So, in a sense, when it comes to, you know, light being emitted from a galaxy or say supernovae, 2 supernovae were just detected that we could see in our night sky. In case you didn't know, you should totally go out and look for it. It's located just above the Leo constellation. And depending on where you are, when you're going to look at it, depends on which part of the night sky, but it was the northeast for a while. And both of these supernovae happened around the same time. One was in a galaxy known as M85, which is a Messier galaxy. So Charles Messier, astronomer, first categorized these. And the other one is another galaxy, really not unique name, NGC 4457. It just Messier catalog and the new catalog. It's two different ways. The point is, both of these supernovae happened, and we can see them now because the light just reached us, but it took 60 million years to get here. And so this supernova that we're looking at actually happened about 60 million years ago. And the other one, 55 million years ago, because both galaxies are located at 2 different distances. So if you want to argue saying, well, that's actually kind of time travel in itself almost, although it's the light that's traveling, not us, that's really fascinating. If we want to look at ourselves as time traveling, for myself personally, I love to recreate time simulations with myself. So what I'll do is I'll sit and meditate, go into super deep meditation for about an hour and start to relive an experience that I once had, like a really awesome experience, like something like when I was a kid, I had a ice cream cone of Rocky Road. And I remember it was like in July and it was warm, and try to remember every single moment that you can, everything that you felt. There was like lightning bugs, there was mosquitoes. I was standing outside the ice cream truck and I went to like, you know, take my first bite of my ice cream, and my first lick, the whole thing fell off and it fell onto the ground. And I remember I could almost recreate that same feeling I felt when I mean, that's kind of a sad feeling. You can also recreate happy feelings. But
Right.
moments later, they gave me a new ice cream and I felt such joy and gratitude. I felt gratitude from the ice cream man saying, oh my gosh, this poor little girl she took one, didn't even barely take her first bite of her ice cream and it fell to the ground. And he gave me another one for free. And that is an expression of gratitude that I then was able to recreate within myself just by reliving that moment. And then it resonated with me for the full day. And so that, in a sense, that's a time simulation, but I almost feel like to achieve time travel, that might be one of the first steps in maybe even starting to achieve it. But now, if we look at the science fiction way of time traveling, that is something that's just completely, not only mind-boggling, but I don't even know where we can begin to actually make it tangible. And that's only because if we were to try to reverse this linear, thing, this entity of time travel, it would be, there's so many ways to go about it. I mean, one of them is, so Einstein's theory of special relativity, which you mentioned a little bit earlier, about time dilation, where, say you're orbiting around a black hole. That's a great example. You're moving very, very fast. And you moving around that black hole could be like 100 years on Earth, because you're moving so quickly. So as you move in different parts of space, or if you're on another planet, even in interstellar, to bring that up again, 8 minutes on one planet can be, 80 years on Earth. And that has to do with where you are based on, your orbit, how fast you're moving, what star system you're in, how fast that planet is spinning around its sun. Your body takes a physical effect of that. We won't stay, the thing is too, that ties in with our circadian rhythm. And where we have a natural rhythm with being earthlings. And so if we were to like be around this black hole and orbiting it, moving at the speed of light, like I said, first off, we would get broken down to photons, but say somehow we remain physically intact, we'd be moving at the speed of light. We can do 1,000 orbits and only a blip of time would be passed here on Earth, because we'd be moving at the speed of light. We could travel the whole galaxy and come back, and it'll be only the galaxy right now, the Milky Way, it was 100,000 light years, but recent studies show it's likely around 250 to 300,000 light years in size. So what that means is if you're moving at the speed of light to get from one end to the other, it would take about the 250,000 years. And so if you were to do that, you come back on Earth, that's about 250,000 years that passed, but you'd be moving at the speed of light. And so you're moving super quick, and like you might very well, if you're still intact, you might be alive and come back and like there's a whole new civilization here on Earth. And that in a sense would be like time traveling. You'd have to exit the current time zone, go into another time zone, and then make it back, and all of a sudden things have changed. And it's like going like we have the time zones here on Earth, and although that's not time travel, you are still kind of like time manipulating. You're going through the time zone. So I'm starting my day fresh when I'm in LA, but I left New York and it was noon, but I get to LA and it's first thing in the morning.
Right.
Yeah.
What do you think, this is the last question I want to ask you before we wrap up. Mm-hmm. In your lifetime, what do you think our big advancements will be in space? Are we going to have a colony on the moon, on Mars? Beyond that, what do you think is going to happen in, say, the next 50 to 75 years that you'll be able to live to see?
I think with the moon, there will be a lunar base. I wouldn't see it as a colony just yet. And a colony would have to, require many, many people that would be living there. And I think that on Mars, we may start seeing like the first human life touching down. But I think that we're going to start merging more and more with technology. I believe that, AI is really going to start to become integrated with human consciousness, human awareness, I would say. And I think that the first people we may actually start to see really colonizing Mars and the moon will be these almost hybrids of understanding both of kind of being more unified with technology and human life. I mean, we're already very close to that. If you looked at the Crew Dragon capsule, I mean, everything was touchscreen. The spacesuits were set up so that it was like, temperature controlled inside, having like maybe advanced eyewear and stuff like that as well in the future. And I think that all of these things, having vital checks on our suits, and but being able to make big decisions, I think that and within my lifetime, we're going to start seeing a major merging between human and machine. And I think that that's going to be definitely directly used for space exploration. I see us having a lunar colony, a lunar base within the next, I would say 15 years, a lunar base. So like starting to set up camps, starting to see things there, people visiting. So astronauts just occasionally making visits, but it's going to be all robotic at first. And I think on Mars, we kind of have a robotic colony there right now already. Yeah. But I think that we do. Yes, we do. They're awesome. I love them. Mars, Curiosity, like all of them. Perseverance, the Mars 2020 rover, all of them. And I think that we're going to start to see people touching down, but I don't think we'll see really a colony for probably 200 years is what I would see as far as an actual colony goes.
How do you address the conspiracy theorists that say anything you see on Mars is a soundstage? it's being shot out in Idaho. You know, like there's a lot of people out there that actually feel this way. How do you address that?
Usually if they speak with me directly, it's definitely tough. I don't have like the greatest advice for it, just because I'm still learning how to have those types of conversations with them. But I always want to encourage them to do the research themselves. And when they do that, they'll say, well, what if NASA's website is a lie? And I'll say, then go to the actual launches, go inside the facilities, because NASA has very, very much open doors. And like, I only know this because of, you know, the NASA social programs that I got accepted into. And you don't have to be a person in the aerospace industry. They purposely accept people to apply to NASA socials that are artists and creators and all different walks of life, so they can really see what NASA is doing. And, you know, you can actually have control over telescopes yourself, and you can take images and process them yourself. And then eventually, to go even further, look into applying to be an astronaut for places like Space for Humanity, to go to space in a massive stratospheric hot air balloon, and then also apply to Virgin Galactic so that you could be part of the space tourism flights, so you can see the curvature of Earth and see that it's round or spherical, elliptical. It's a spherical elliptoid. But then also, you know, look too at the history of, you know, as far as people saying that the moon landing was fake, and like, look at what was going on just on Earth during that time, and who were quote unquote allies and who were quote unquote people were looking at each other's enemies. And if we didn't go to the moon, who would have been the first ones to call us out? Like, definitely, it was a huge rivalry at the time. Like you said, it was militarized. And so if France found out that we didn't go to the you know, or the Soviet Union found out we didn't go to the moon, they would have been the first ones to be like, wait a second, the Americans, they're not true, you know. And they would have said that. They would have called us out so quickly because of human pride and ego. And if we look at just the logic of that, that to me is enough to know that it is true. But then you look at all the evidence, talk to astronauts, they're at events. You can literally, well, not during COVID now, but you know, you can literally talk with them, and they might say, oh, they're all programmed and they're lying. But really get the true raw stories from them. It's different when you look into their eyes and you can see the experience that they've had. And that is far beyond, you know, saying that these things are fake or staged. It would be a vast conspiracy of manpower alone to cover up something like that, which is, there's just too many people, too many stories, and had too many parts in this that roles to play to build these things and to put people where they are. I think it's all really fascinating. Obviously, with topics of my podcast, there's a lot of conspiracy theorists I get email from. So I love going head to head with people, you know. No, of course, you said get on the Virgin Atlantic flight, get on the Virgin flight into space, but most of these conspiracy theorists can't afford that. So though that's why I mentioned like Space for Humanity, because their whole purpose is for people who can't afford Virgin Galactic, which is like $250K. Space for Humanity is collecting people that they will actually directly fund to go to space and get this experience. And this is something Dylan Taylor, the CEO, great and founder, great friend of mine, and he's been working on this project purposely to bring that cosmic perspective and overview effect to people, everyday people, everyone who has the right to see our planet as this pale blue dot. And I think that that's super important, because you're right. Yeah. Virgin Galactic, extraordinary place, extraordinary company. I love what Richard Branson's doing. And, you know, Hidalgo Whitesides, I love Loretta and George. And, that right now is going to be more pricey. But also look at airlines. Flights were so expensive, only the elite could fly. And now anyone's flying. And so that's the whole goal with space flight as well. And that's what Elon Musk also wants to achieve, is to allow for space flight to be as quick and reusable, and just, you know, you refuel, change out the food, clean up the plane, and boom, clean up the rocket, and next launch. And that's what, you know, essentially is going to happen. And you will see prices go down. And I think that people will hopefully start to realize that.
I love what Elon Musk is doing. It's the vision of the future that I expected to see growing up, loving 70s and 80s science fiction. This is what I wanted the whole time. Everything he's building is the style of what I was hoping we would get, that would look like the future, and it's happening, and it's working well.
Yeah, it's amazing. I love it.
Athena, I really appreciate you doing the podcast today. You're so fascinating, and there's so many other little side roads I would have loved to have taken today. This idea, you piqued my curiosity on merging AI with people. This merging of human and tech is a road I'd love to travel at a different time if you ever want to talk about it. But I want people to know how to find you out there. So you have a .com, you're on Instagram, Twitter, TikTok, you got all kinds of cool stuff you're doing. How can people find you?
Yeah, well, thanks so much for having me on first off, Todd. This has been so awesome. I love being able to explore these other concepts, right where science meets metaphysics. So yeah, all my social media is Astro Athens, all one word, Athens like Greece, and then Astro like astronomy. And that's both, like you mentioned, TikTok. I started doing a lot of like DIY astrophysics demos because it's a younger population mainly on there for kids. And then I have my website. So I have both a launch ticker for upcoming rocket launches, different interactive features on there that I'm creating right now. And my Instagram, my YouTube channel, 2 series, the lecture series, the original series. And then actually 3 series, I guess. And then I also have Cafe Astro Athens, where I relate the cup of coffee of the day to a topic in space, just to make it as casual as drinking a cup of coffee,
I don't think I've seen that one. I'll have to tune into that.
Oh,
you have so
yeah.
much programming out there. I got to see more of it. So, let's talk about space crime with Dr. Julia Shaw, because I'm a big fan of this. Tell everyone about this.
Yeah, so Dr. Julia Shaw is a criminal psychologist. She is extraordinary, and she's written lots of books, done TED Talks, and she recently, her and I connected, and she said, I want to go into astrophysics, like teach me. And I was like, how about we make a podcast about that? And we merged her industry and mine and started saying, like, when humans explore like Mars and start setting up a colony, most likely we're humans. There's going to be crimes happening in space. What does that look like? What is legislation going to be like? What is space policy going to be like? Is there going to be a space jail? How are we going to handle criminals in space? And how are we going to handle what a crime is? Are we going to handle what's problems we're facing here on Earth? How are we going to deal with stuff like that in space? And so that's what our show has been like. We do it on Wednesdays at 12 p.m. Eastern time. On Instagram, we switch off between my account and hers. Hers is Dr. Julia Shaw on Instagram, and mine is Astro Athens. And we do alternating weeks on our Instagram lives. So it's been really fun. She's great.
It has been. What are the next topics you have coming up?
So we just finished talking about terraforming Mars. So now we're going to go into, that was more on my field of view. Now we're going to go into her field of view of, okay, how is that going to make a psychological impact on people as far as, what we're going to really need? Because we spoke about what we need tangibly. Now we're going to talk about what the human mind is really going to need, and like what type of ailments or mental illness is what might be a result of these long-term isolation periods.
Yeah,
so that's what's going to be next.
It's fascinating. I can't wait for it. So I'm going to close with one of your quotes that I really like on your website, and you say, understanding where we came from is only the start. And I think that's beautiful. It really is. And I want you to keep doing what you're doing, and keep putting the word out and talking about this, and just being a voice for space, and talking to young people about it, and explaining things to people, because you certainly explained a lot to me today. And I think that the listeners are really going to enjoy this.
Thank you so much, Todd. Yeah, that was incredible. So yeah, I had such a great interview. And I'm so glad you shared that quote as well. I wrote that very long time ago. So thank you.
Yeah, no problem. Thanks for coming out today. Okay.
Yep. Thank you so much. Have a great day.
You too. Bye-bye.
Bye.
And there you have it, my interview with Athena Brensberger. I hope you enjoyed it. Be sure to join us next week on Quest. Thank you for listening to Quest. Please be sure and rate and review this podcast. This podcast is copyright Any previously trademarked or copyright content is used by permission. Be sure to visit the official website for the International Association of Metatomics at metatomics.org, or find us on social media for other unique content. And make sure to pick up a copy of the book that started a spiritual revolution, Metatomics, The Grand Design, available for sale online and at most major bookstores. Thanks for listening.